we decided to implement our radar system on a software called GNU Radio Companion, which is an open source platform to build wireless communications. Each block you see on screen right now are readily available modules that you can configure to suit your needs. We designed the transceiver we are going to test now, which will send out a continuous signal on the 1.2 GHz radar band and try to receive it with a viable SNR for further signal processing. So here you can see the transmission signal that we are sending out and that we receive it with minimum distortion. You can also see the signal in frequency domain, and the band is centered on the L-band radar frequency. Now let's see what happens when we change the frequency of the transmitted signal. So as you can see, in all cases we receive the frequency varying signal without any problem. So in conclusion, we can say that our model can be used in real-world radar that operates on L-band frequency for target detection.
Here you can see the moving target detector that we used in order to do the radar signal processing. From mid-review to the final demonstration, we did many changes in order to build the complete MTD. As you see here, several of the data processing blocks which were not implemented during the mid-review has been implemented now. Here we use the 3-pass cancel in order to reduce stationary clutter such as mountains. What it does is pretty simple. It gets the negation of 2 consecutive passes. Moving targets will not cancel out since there will be a magnitude difference, and only the stationary clutter gets removed. So we follow the conventional MTD and use the 3-pass canceller in order to get wider clutter notch and great clutter attenuation. The stationary clutter that was not removed by the 3-pass canceller will be removed with the help of the Doppler filter bank and the zero velocity filter. Now next we will look at the zero velocity filter. The zero velocity filter here isolates the ground clutter from other moving objects. This is a low pass filter which passes the components with low Doppler frequency shifts. It runs parallel to the 3-pass cancel and Doppler filter bank, and you can see the output we generated from this zero velocity filter. The output of this is used to update the clutter map memory, which outputs the clutter map threshold. Since the clutter map threshold is regenerated for every scan, even in conditions where the clutter keeps changing, threshold will change according to that. This was used as the threshold in the Doppler filter bank in order to remove clutter entirely that could not be removed by the 3-pass canceller. Output of the 3-pass canceller is converted to range Doppler map and sent to end-pass Doppler filter bank. The end-pass Doppler filter bank is used to differentiate targets using the Doppler frequency shifts. Each of the filter output will have its own threshold. For filtering using the end-pass Doppler filter bank and thresholding using the clutter map filter, you can see ground clutter has entirely been removed. Now only you can see other targets and moving clutter. But still we are not sure where our actual targets are, which are airplanes. In order to do that, we use velocity filters. These are filters for specific objects which have cutoff frequencies equal to that of the Doppler frequency shift of those objects. As an example, if we want to identify airplanes from here, first we have to use the average velocity of that specific airplane, which can be found in radar literature. Then get the Doppler frequency shift for that velocity in order to design the filter. We design filters for cloud clutter and airplanes. Here you can see the clouds in the first diagram. Here is the final output that we expect only with the targets which are airplanes. This is how the targets can be seen in radar screen. The data we had was for a single azimuth angle. When the radar rotates, for each angle we will have to do the processing again, and the radar signal screen gets updated. That is how we completed the MTD radar signal processing work.